Hello everyone. So this is part 2 in creating the projectile shooting setup here and on our player. So right now we do have projectiles being instantiated in the world and firing, and a sound effect, and they're being cleaned up out of the world so we don't have a bunch of clones out there just flying around. The only problem is nothing is propelling our projectiles forward in the world, so they're technically not being shot out. So what we need to do is make a script that will actually go on our projectile that will propel it and give it forward motion in the world and a speed, look at speed. So we're going to create a new script and C#, and we're going to call it, oh god, we're not going to call it that. We're going to call it laser projectile. We're going to select our laser object and just left mouse drag this script on and double click it to open up MonoDevelop. Mono develops. Okay, we're nice and zoomed in on our script. So make sure this class name in the script matches the actual name of the class in your hierarchy. So in our little space here for setting up some variables, we need to set up some variables for our projectile object itself. And what we're going to do here is the first thing we want to set up is a public variable. It's going to be a float, so floating decimal point number, range of values. We're going to call it speed, and we're going to set it to 2. We're going to put the little F for float behind it. And that basically is going to say how fast our projectile can travel through the world. So here we have speed, and we can scrub that value, negative speeds, positive speeds. Just leave it at 2 for now. Let's create another variable. I'm going to make this one publicly visible in the inspector. It's going to be an int, which is an integer, a whole number, 1, 2, 3, 4, 5, 6. It doesn't float, so it's not going to be a 0.01. It will just be a whole number. We're going to call it damage. We're going to say it equals 25. Now, this is going to be, when we see it here in the inspector, when we scrub it, it's a whole number. Okay? It's going to be the amount of damage that this projectile is going to cause the objects that it hits. Okay? Damage to other objects this object strikes. Okay? And we'll comment this one and say speed at which the projectile travels in world space. Okay? Okay, and our last second to last variable we need is going to be private. We're not going to adjust anything in the inspector for this. It's going to be a type of transform, and it's going to be this transform. We've done this in the other scripts before, and this is going to cache the transform of this projectile up front so that the update method here, or function in UnityScript, is not going to be looking up the transform of this object every frame. It'll be cached up front, we'll have it, we can pull the information and use it here to do things with that transform. Okay? So we can put that there. We can type that, cache transform for this projectile. And the last variable we need will be public, so we can see it in the inspector and assign something to it. And we will call it, it's going to be a transform. And we can call it the bullet, this isn't a bullet, laser hit effects prefab. And that is where we're going to be able to assign in a particle effect that will be spawned when this projectile strikes something. So pieces of metal or pieces of rock, depending on what it strikes. Okay, so that's it for our variables. Let's go in the start function, and I've described in other tutorials, and the start function runs when the scene starts, and that's it. We're not accessing it every frame. You hit the play button, it runs this start function, and everything it's found or done in that function is done with. So we just want to take this transform and assign that empty variable up here. This is going to be empty by default, and just say it's equal to the transform of this object. Might be kind of redundant, but if you just picked up here, when we reference this transform, it's just grabbing this transform component. on our laser projectile. So that's cached. That's taken care of. We can move down into our update method here that we want to occur every frame. Update is good for checking things like the motion of objects, the physics of objects, and keyboard input, any kind of input from the mouse or the keyboard or touches on a mobile device. So in update, we just want to say this transform, which has been assigned to be this object, its position, okay, its position in the world, is going to be plus or equal to time, so time in our game, times the projectile speed we set, and this transform.forward. And this transform.forward is like a shorthand. Oh, I forgot another multiplication. It is a shorthand for basically a vector 3. So forward means down the z, down this little, if we look at our ship, we will want to propel our projectile down the z, so facing forward of the ship. If this were this transform up or right, it would go up in the y. So it's basically like a vector 3 of these positions for the projectile. So that's giving it its motion actually right there. So we're caching the transform of the projectile, then we're taking that cached thing and we're saying its position in the world over time is multiplied by the speed of it and moving forward in z. Okay, that's everything we need to do. If I hit Control S and we go back, let's take a look at our projectile first. Are we giving it a speed? Let's give it a speed of 10. And okay, so the laser hit effects prefab, it won't error out. What we're going to do is we'll do some shooting. It shouldn't error out because look at that. And then they'll travel so far and then they disappear. Okay, and we're firing by our fire rate, which is pretty cool too. If we go back in the player script, we set the firing rate to like 1/10 of a second here. Boom, we can fire a lot. Pretty neat, right? And also vice versa, if we set it to something high like every 2 seconds, say this is a weapon that had to we can only fire every 2 seconds. Alright, we also have a problem going on that the projectiles, when we're traveling at speed, they're not taking off quite fast enough, so they're kind of lagging behind the player. We can take care of that. A more complicated, well, semi-complicated method would be, and we'll do this in a later tutorial when we go back and revisit the player shooting with the homing missiles, is we want to take the player's speed and add that on to our projectiles so that when they fire matching the speed by default of the player as well. But honestly, this is just happening right now because we're not giving the projectiles enough speed. They don't leave with enough speed. And they should actually travel really fast anyway, see? I'm going to go back and change the firing rate to be something reasonable again and hit apply. Okay, and we'll travel, and there's enough forward motion now that they're definitely firing forward of the player. And they could actually travel quite a bit faster. I don't think the speed is actually enough. So we'll go 150. The other thing I noticed is I'm going to drag this laser prefab over and hide the player. I don't like that the laser is actually leaving behind such a long trail, so let's make the trail shorter on it. Hit apply. Delete it from the scene. Re-enable our player. And I want to see a shorter trail. And so we got shorter trails, which is nice. And the projectiles are traveling out into space. Which is kind of neat. Slow it down so we can see those better. So we can fire at stuff. And we can adjust the speed of the projectile, the damage it makes on other objects. We can also go in and set our firing rate. we can actually go back into the player shooting script, and since we're assigning cooldown to fire rate here, all we really need to be able to adjust in the inspector is the fire rate. So let's go ahead and just make the cooldown private. That way nobody can mess with that value and kind of jack it up ahead of time. All we need to adjust is the firing rate. Okay, so back to our projectile. We want to be able to damage some things now. So we need to do some checks. Let's go back to the projectile script after update. And what we're going to use is another method, and it's a built-in one called on, if I can type it right, on collision enter. And we're going to say we want to enter into a type, an object type of collision. So we're looking in the world for that, and we'll give it a temporary variable name of just collision. And of course we want to do some things when this projectile object does enter collision somewhere. Let's do some checks, and let's ask a question like what kind of collision is it going to enter? So let's say if the collision, which is that temporary collision variable, dot game object dot tag equals enemy. Okay, then let's do some stuff. Some more brackets to cause some things to execute here. And let's say collision dot game object dot send message take damage, comma damage. We'll explain this. Send message options don't. Okay, I think that auto typed that out. Let's see. Yeah. Okay, and so I need to go a little bit wider. Okay, so what we're asking is when we enter the collision, this projectile enters the collision. If it collides with a game object that has the tag of enemy, then do this. And then we're saying take that object that we hit, the collision here, this temporary variable, that's this object or the enemy that we hit, take the game object, send a message to it called take damage. And basically what send message is going to do is look through the scripts, all of the scripts applied to your enemy, and it's going to find one that has a method or function in it called take damage, and then it's going to apply the damage amount up here that we set to that object in that script. Okay, and then send message options don't require receiver just means we strictly are not requiring an object to receive the message. So that works for sending the message to take some damage. So we can actually just leave this be for now and actually set up the health script on the player. So give me just one moment. I try to reference the scripts that I've written ahead of time. And so what we need is we need a health script on our enemy object. So first off, let's create a cube. Let's just move it out there in space somewhere. It doesn't really matter where it is. Scale it up a little bit so it's easier to hit. You can kind of make it look like a ship. I don't know. We can call it enemy. And then if you remember in our script, we were asking if that collided object that we collided with, if they had a tag called enemy. Tags are very handy in Unity, and they're up here on the object and under tag. And it's not tagged. So up here you set the size of the amount of tags you want. Let's give yourself some options. Type in enemy. Now we can tag this object enemy, and its tag is set. Okay? It has a collider on it, so it has collision when we hit it, and it has a tag enemy. Right? Nothing's going to happen if we were to hit play and hit it. It just passes right through it. Okay? Nothing is actually occurring. Okay? It is registering that the collision has entered it, but it's not saying to do anything with any of the object anything on the enemy. So let's create a health script for the enemy, and actually this health script will be applicable on any object in the world that you'd want to destroy. In fact, later on in this tutorial we'll put it on asteroids, and they'll have a health. So when the projectiles hit an asteroid, you can give them like a health of 5, so one laser hit will kill it, destroy it. So let's right click, create C#, and we'll just call it, I cannot type, health. And anything that we want to be able to destroy with projectiles, we would put this health script on. We're going to double click that and open it up. Okay? And we're going to go a little bit quicker so we're not like a 40 or 50 minute tutorial here. Okay, so the first thing when we think of a health script, that we want these objects that we're going to destroy, whether it's an enemy AI or an asteroid or an enemy cargo ship, is its hit points. Okay, so let's create a public float, and we'll call it hit points, and let's just set it by default to 100 at. It's 100 hit points of health. Okay, the next thing we want to track is another public float. We want to say current hit points. Now, we're not going to give this a value because this is actually going to be tracked lower and down in the script further down, and it's going to keep track of how many hit points the player currently has. You could actually call hit points max hit points and think of it as max health, current health. Okay? Normally the current hit points or the current health, you could make that a private and hide it, but I keep it public for debugging so that we can look at the enemy and see where his health is currently sitting, and therefore look at it and see if it's being reduced. Okay? And then the next variable is the last one we need, and it's going to be a game object type, just a generic game object, and we're going to call it destroyed. We'll just call it destroy effects. And this is just going to be a particle effect or any other type of game object thing you want to spawn out when this object is destroyed. We're going to work on some asteroids later, so that when the object is destroyed on the asteroid specifically, it would spawn like rock particles. If this is on your AI metallic enemy ship, the destroy effects would be like pieces of metal, fiery metal, and maybe smoke or something like that burning off. So we're going to go down into our start function, which is when we hit play, and we're going to say in our start function, current hit points are going to equal hit points. And what that's saying is very simple. It's just saying when the scene starts up, his current hit points, that asteroid or that enemy, is going to equal the max hit points we allowed. So he's going to start with full health. Okay. Now we're going to go down and create another method or function in Unity script. And we're going to make this method public so it's accessible outside of this script. And I'm going to explain why that is in a minute. Okay, and then some brackets for this. Okay, so this is a public function or method that's going to take place, and we're passing into it in an amount, a float amount of basically the amount of damage, but within this script we need to access it locally. Notice the name of it, take damage. If collision game object hits a tag named enemy, send a message, take damage, and then send into that function or method the damage amount, 25. There it goes. It gets sent into this, the message gets sent, it sends in that 25 damage, and it applies it into this amount, temporary variable right here, float. So now this script is aware of the amount of damage it's taking. Where were we? Take damage. Okay, so in take damage, we want to say the current hit points of this asteroid or enemy AI is going to be minus or equal to the amount. There we go. It's literally taking the damage. So if we hit Control S and save, now we've given our enemy health. Okay, he has 100 hit points. Our projectile laser is causing 25 damage each time. So when I shoot, and we hit this tagged enemy, his current hit points are 100. He's ready. He's 100%. Now he's reduced by 50. Now he's reduced to 0. He's negative 50. He's going into the negatives because we don't have any check for limiting how much he can keep taking until he dies. It's working. It is totally working. These projectiles, where did he go? Alright, somehow I flipped around and lost him. Boom, he took 25 damage. See, it's hard to see when it's hitting, and that's where that damage hit effect actually really helps. It shows you when certain projectiles strike. If we kind of look from his vantage point and I fire, let's try to get, we can see they come really close, and to us, see, like that looks like I'm hitting him. See, in game window, looks like he's being struck, but he's not. Requires a bit of accuracy. Now he's being struck. Damage is going down. So you can see why I kept current hit points public. So we can just see. But honestly, you can change that to private and we don't have to even look at that. So he's taking damage. And he's taking the damage amount from the projectile. It's sending it into this health script that is on your enemy, or this is an asteroid at this point. We could just say this is some kind of space debris we want to destroy. And it's getting reduced right here. So now that it's being reduced, let's do a check and say, well, if this guy's current hit points when he's taking damage, if they're less than or equal to 0, make sure we don't go any lower than 0 and that he dies. Okay, so let's say current hit points. Okay, let's ask a question. If current hit points are less than or equal to 0, then put some brackets in here because we want to do something. And what we want to do is we want to make sure current hit points are equal to 0. They don't go below it. And we're going to make a custom function, not called dictionary entry, or custom method, whatever you want to call it, and we're going to call it die. And honestly, we don't even need to update. These are things that are only going to occur when collision's been entered. So now let's shoot him and see if he goes below 0. The current name die does not exist in the current context. That's true. We're calling a function here that does not exist. So, outside of take damage, let's create a new method and call it die. Make some space for us to see what we're doing. And for right now, we'll just use a debug.log enemy object has died. And a debug log just will, all it will do is when we go down here into the console, it'll print a message in this console. Very handy for debugging stuff, i.e. probably why they called it debug log. Don't leave these in. When you're finally ready to start testing and shipping your game, comment all these debug logs out. It's actually really expensive for some, to be printing things out to the console log. It's great for testing, but not good for final development. So he should not be able to go below 0 hit points, and we should see a message that said he died. Okay, what happened? Where are we at here? Okay. So he's being reduced, and he's 0, and he's not going below 0 hit points, so we're not having an error. Okay? And every time we've struck him with a bullet after that, he's died. I double click it, it takes me right to the line. Our method for dying is being called. Perfect. Let's comment that out since testing shows it's worked. Actually, let's just remove it. We're not going to need that in a minute. Where we're going, we don't need roads. So we want to ask a question when his hit points are 0, and he's basically, I'm going to die now. We're going to say if GameObject.tag equals enemy. We've seen this before, earlier. Then we want to do something. We want to say, alright, if it's dying, and it's lost its health, and it's an enemy, okay, it's tagged with that, then very easily we will instantiate that destroy effects at this transform dot position and this dot transform rotation. By the way, I love Back to the Future. And then after we instantiate that, let's actually destroy this game object that we just killed. Make it disappear, make it go away. Now this will only occur when something's reached this condition for dying and it's tagged enemy. Okay? If it's anything else we're hitting, it will not do anything. So what's happening is we're just instantiating that destroy prefab, that destroy effects. That'll be our particle effects. And we're instantiating it at the transform position of this object that has the health script on it, right there. This is not being called every frame, this void die. It's only being called when the condition for die is met and when the collision has entered. So just immediately, one time. So what we do in this case, instead of caching the transform, we can just say this object, its transform position, this object's transform rotation. So when I hit him, it's probably going to complain about not having a particle effect for his destruction. I wonder why that happens when I... Where did he go? I'm not gonna... Okay. Okay, let's... Alright, he's being reduced. Yes, it complained. That's pretty cool. I'm gonna make for... If this was a real model of an enemy ship and there were particle effects, that would make for a neat screenshot. So yes, we don't have a destroy effects on him, on his health. So we better go and create that. Let's just easily go create other particle system. I want it at world center, but I'm going to keep it here for right now so that we can go and tweak it. We don't want it to loop. We'll spawn out about 25 particles. Let me move this window. Okay. Lifetime's too long. Why don't you just spurt out quickly. Start speed. Let's let it kind of just... Okay. Shape. No, we don't want to do that. Let's change the radius to be kind of wide. Just say radius of 90. Okay, maybe too much. That doesn't make any sense. It shouldn't have been much bigger than that. And then velocity over lifetime, let's say 2 should go out in all directions. And it's not. Maybe world space will help. Well, sort of. It's still going up. So let's see what we can do. Okay, let's limit the max amount of particles to 52 first. Let's try force over lifetime. I think that's the individual velocity. So let's put just like 5 in there. Okay, and let's set it to world. Okay, that's not very helpful. Let's just bring the Y down. And we'll use velocity as well. See if we get it spreading out. Why not mess with particles? No, let's give it more of a speed. My bad. Okay, that's actually much better. Alright, let's give it higher speed and shorter lifespan. This will not be like a particle effect you would use. And let's go and grab that material down here in the renderer. And let's drag in that laser beam material and see if that will actually... Nah, it doesn't actually work very good for this, does it? Let's Control Z that back out. Alright, let's not get too caught up in making the particles look nice. So let's reset its transform and see if it's visible underneath. Okay, yeah, that definitely shows. That'll definitely show you. Okay, so let's create a new prefab and call it destroy effects. Okay, I'm trying to keep track of. Call this destroy effects. I'm trying to keep track of time here so we don't go too far over. And hit apply. And now we have a prefab particle effect for the destruction of objects. We shouldn't get that error anymore. So let's go look on our enemy and let's just drag in the destroy effects. Now let's go create prefab and actually create a prefab out of him too. So basically when, let me reset the position. Well, we don't want to reset the position in our case right now because we want to be able to go out there and shoot him, but let's just scoot him back out there. Put him out a little ways. There we go. Because normally this won't exist in your scene by default. He'd be zeroed out at world origin and you'd have him as a prefab. And then later on, well, we're actually going to do this in our setup for spawning enemies. He'll be instantiated into the world dynamically, so he's not going to already be existing there. But for these testing purposes, we'll do it this way. So he's got his destroy effects on there, what particle effects that would be spawned when he's destroyed. I wonder if I can hit him from... And boom! That worked like a charm. Now, dead, done, destroyed, he's out. Now, the other issue is too, is our particle effects clone that was spawned off of him, it's empty now. It's played the particle effect out, but it's still existing in our scene. So there's something we want to add we've already created to that particle effects to kill it, basically destroy it from the world. We're just going to click Add Component and remove that. Scripts, and let's just do the self-destruct on him. And we can say 2 seconds, 1 second, however long your particle effect is. If the particle effect takes like 3 or 4 seconds to spray all these pieces of cool debris off, and it takes like 3 or 4 seconds for it to play out, set it to allow it. It's not destroyed until that's done. So now when I hit this, we won't see our destroyed effect. Oh, I missed him. Let's bring the engines down so we can find them again. Golly, I need to really tweak the engine speed. Am I hitting him? Alright, let's go forward a little. Obviously we would want to remove, yeah, there we go. We'd want to remove that engine text and put it up in a corner in the UI or something properly. So he was destroyed, and now his particle effect is not hanging out in the world either. Okay, so we've cleaned up the scene. Let's hit File, Save Scene, and Save Project. Let me think about... okay, we have just a little bit more to cover. Let me take a look at this. Going back, so this is if we hit, this is back on our projectile, on the laser. The laser projectile script, okay, which is this. We're only checking right now if we hit something called an enemy. But if you want to hit something other than an enemy, like environment, like an asteroid or some other thing, I'm going to Control-C, hit Enter, give myself some room, and duplicate that. And I'm actually going to change the tag name to something like props, I think, yeah. Or just prop. So now we're asking, if we hit an enemy, do this. And if we hit something called prop, then do this. Okay? So it's actually pretty cool. We can spawn. So I'll explain what we're going to do with that in just a moment. Because right now this makes no difference. Regardless, it's not going to do anything different. If it hits a game object with a tag enemy, it's still going to just send damage to the help object, and a prop, it's just going to do that. But these really are not the important line here. So we're going to add in the next important part, which is going to do a check just on collision enter, so not every frame. And we're going to find some stuff here, and I'll explain it in a minute. Oh, no, dot, not a comma. Okay, and I'm going to type some stuff out. We'll type this all out together. And then, we spelled that wrong. That's a fail. Equals quaternion from to rotation, vector 3 dot up, contact dot normal, close that out. Okay, backwards symbol. Okay, we're almost there on finishing this up. The position is equal to the contact. Good thing is, once we type this up for the enemy, we can just copy and paste this for the most part right into the prop. So, okay, another instantiate, and then you're going to ask in a moment, well, what are we? Laser hit, effects prefab, position, rotation, and destroy this generic game object that we've hit. Okay, so before we copy and paste this, first thing is we hit this game object with the collision and its tagged enemy. We send a message for the damage. We saw that working. The next thing we want to do is, this is all for some things. Now we put a self-destruct script on the projectile. Okay, so what do we got here? Are we missing some stuff? Ooh, vector 3 update. No, up. Okay, so on our script, on the projectile, we never signed a hit effects prefab. Now on the enemy, we put an effects prefab for when he's destroyed, the pieces and shards come off of him, like, you know, or you could just spawn like a dead floating burn up version of him, not even just a particle effects, but like a burn up crusty piece that's just going to kind of rotate and float off into space. And we can do that. But on the laser prefab, we didn't set up any hit effect, like when a bullet hits something like metal, the sparks fly off or something like that. So that's what we want to do. We have a variable for that prefab to be spawned when this projectile hits the enemy. This is not killing him, this is just sending damage and hitting him. So here's some semi-complicated stuff here. This is built-in Unity stuff. Contact point, we make a temporary variable to reference this built-in Unity thing, and basically it's a way internally in Unity for it to determine the point of contact on that collision. Where did this projectile's collision enter into the collision of the enemy? Exactly on what point on the surface? And we just look at this collision that we've entered here again, and its contacts an array. So there's like a bunch of different possibilities. It could hit on the top side, the left side, the bottom, the right side. So it's an array of contact positions. Quaternion is just a Unity internal thing representing rotations. We give it a temporary variable just called rot for rotation. And all that is just saying at the contact normal, which a normal is kind of like, if you ever seen face normals on a 3D mesh, it's a vector coming right off the center of the polygon, like of the collision, the top of it, the side of it. And we just say, this is the rotation. So the particle effect, when it's spawned, we're going to use a rotation based on the normal of that collision that's been struck. So basically the angle of its surface in the world. So basically our particle effect will spawn in a cool way off the surface naturally. And then we give it the rotation. We also have to give it its position. And we just say the position that we want to spawn this will be right on that contact point. Where did it contact the collision? and then we just give an instantiate that hit effects, sparks, smoke, whatever, prefab, and then we instantiate it at this position, the contact point, and this rotation, the rotation on the surface normal. And then once it's done instantiating this striking effect, destroy the laser projectile itself. Don't destroy the prefab for the laser hitting, but destroy the projectile. So we did a self-destruct script on the projectile for if it goes out into space and hits nothing. This is what happens when it hits something. So we can just go Control C, Control V, and we're good to go. So the cool thing is since we're instantiating this hit prefab thing, let's go back and look at our projectile. No errors, hopefully. So now you see kind of the power of this. We can install an effect for striking something. And, well, I think later in the homing tutorial, we'll set up another different type of prefab. Instead of calling this the laser hit effects, we can call this like the enemy hit effects prefab. And so if it hits an enemy up here, it spawns a specific type, a different prefab particle effect if it hits an enemy. And then we'll create another variable for like prop hit effects. So if it hits something that was made of metal, sparks, hits something maybe made of, say an enemy ship was made of fluid, it spawns some kind of goopy liquid or something. It could spawn different particle effects. That's why we have separated the collision check for props and tag, even though technically we're not. For demonstration purposes, we are not really using it. So let's go back in and test this out. Now, I don't want to create a whole new prefab and all of that. So for the destroy effects, I'm going to drag that prefab over. And I'm going to go game object break prefab instance. So now it's no longer connected to this prefab for destroy. But it is the same exact thing. I'm going to call it hit effects. And we'll go create prefab hit effects and drag it in, and that's an easy way to make a new prefab from an old one. We definitely want to make sure the self-destruct script is on the hit effects too, so it's destroyed and cleaned up out of the world too. The other thing is, so we should make the hit effects look a little bit different. So let's just do color, and anyway, you can go in here and throw any kind of random colors you want, but I'm just going to put those so it looks wildly different. And I'll change the size and the lifetime much shorter. Okay, we should be able to see that that's different than the destroyed effect. I'm going to reset its position. Okay, and I hit apply, so it's applied. So now on our laser projectile, we can fill in this hit prefab. And when we hit play, we should see the bullets striking. Lasers. I do so much like FPS stuff that. Okay, let's fire. And I saw it, yes. Boom. And, well, his health is pretty low. Let's give him better health. Hit apply. And this way he can last a little longer and we can see. I can't hit the broadside of a barn. Okay, there we go. So it's coming off of him. Boom. And he's done for. So what we established in that is now we have a particle effect coming off of the enemy when our bullet strikes him. And actually, it looked a little funny, like it was coming from the inside of him, because this is just such a dang broad particle effect. But usually for hit effects, they're really tight little little things. So we just need to change the radius to something much smaller. Get a tighter. Oh, that's way too packed. And I just don't work with freaking particle effects enough, because I just don't. I don't like how it's not spreading out. You know, this might be having to do with not the radius, but the angle. Maybe. Let's go back to a high angle and a tighter radius for this. That's a little better. I don't know, let's hit apply to our changes. And just so we can kind of see it a bit better. We're not hitting him. Sure looked like we were hitting him. Okay. The other thing we might want to do is in the future, and we'll do this when we progress further on this, is the problem is it's instantiating here, well, supposed to be, and it is technically working how it's supposed to, but the rigid body is passing through so quickly that by the time it gets that instantiate call, it's kind of already, I want to say it's already kind of inside the collision. It's passing through the enemy already, and it's a little delayed. So there's some things we're going to do here when we come around to the homing missile script part that we're going to do to kind of fix that, so that we can offset the we can probably offset the spawning of that hit effects down the z-axis a little better, so that it actually appears on the outside of the craft rather than directly inside. So stay tuned, and in the next tutorial we're going to start working on having a game manager script in the scene and basically instantiating the player and enemy versus having them already in the scene for testing. So stay tuned for that. Tutorials should be coming in the next few days, and thank you for watching.